Hello, everyone. Well, yeah. Okay. Hello, everyone. Welcome back to the What is ISO series. And today we'll be talking about what is the International Olympiad of Informatics, or IOI. And we have here with us Wei Xin. Wei Xin has been the Malaysian team leader for the International Olympiad in Informatics since 2019, when he started as the deputy team leader. Currently, he's in his third year studying computer science at the National University of Singapore. Wei Xin is also an IOI alumnus representing Malaysia in 2018. He is now the president of the Malaysian Informatics and Programming Society, MIPS, which manages the national selection test in Malaysia for IOI. Hello, Wei Xin. Glad to have you here with us. Can you tell us about the national selection test for the International Olympiad in Informatics? How is it done and how does MIPS play a part?
Yeah, sure. I guess I can start by sharing my slide first. Let me know when you guys can see the slide.
Yeah, we can see it.
So, all right. So, yeah. So I suppose I should just start with what is IOI to begin with. So essentially, IOI is the international computer science or programming competitions for secondary school students. So it's held yearly. So it's alongside it's one of the five major ISO or International Science Olympiad, along other subjects like math, physics, chemistry, and biology. So each year, each country will send four students, and for 2 days, the students will engage in some very challenging programming and problem solving. So yeah, you'll be competing with some of the best in the world, and the task you face is also like very challenging, and it's very fun. So if you are any interested in programming or even problem solving at all, you should definitely try to give IOI a try. So suppose that but unfortunately you cannot just just register and just go. So you have to undergo some selection process. So how it works in Malaysia is, so you not typically will start with MCC, which is the all right. Yeah, so I suppose I'll just illustrate the overview of like the selection process. So typically students will start from MCC, which is the Malaysian Computing Challenge. You will start depending on the respondent rate, it's around 300 to 400 students. Then after that, they will undergo some more selection. The next major stage I would consider will probably be MCO. After that, you have a APIO. Then finally, from all these selections, we try to pick the top four students to represent Malaysia. Indeed. Yeah. So then let's just start with MCC first. So what is MCC? So it's just an online competition designed to evaluate participants' computational thinking abilities. So it's just we want to test if are you able to trace through are you able to think like systematically, think in terms of like algorithm, be clear. So at this stage, we do not require you to have knowledge of programming yet. So it's really intended for beginners, or rather anyone with any interest in computing at all. So if you're interested, you can just join. So the programming knowledge is not mandatory, but it might be helpful for like harder test cases because uh, yeah. So how it works is you will be given around 5 to 6 problems, and each problem will have a few cases, and you will only need to calculate the answer to the cases. So you will have a problem, each one will have a few case. You just calculate it one way or another. We so we don't really care like how you get the answer without cheating, of course. So but you pen and paper, Excel, programming, etc. Anything is up to you. So it's really just to test, are you able to understand the question? Can you try to find a good solution for it? So I think it's probably good if I try to illustrate, what kind of problems are we even dealing with to begin with? Because right now it might still not be clear what kind of problems you will be seeing. So yeah, so this is just like a sample problem. Like for example, I'll give you like a list of number called list, and you have to calculate the sum, right? So for example, the first case here, you will see that actually, can you guys see my mouse pointer? Yeah, can right. Okay, so yeah, so there's a list here, and it says tree number 310.5, and to calculate the sum, then so this will be sort of, so this is the problem, and this is like one of the cases. So you can just or maybe you think, oh, okay lah, just elementary school math, then you just calculate 3 plus 10 plus 5, 18, and you submit 18. Okay, you get it for this case. Then similarly, so each problem will have a few cases. So this is the same problem, then this could be like case 2, for example. So the second case would be, oh, okay, the list is now 5 numbers, 10, 9, 16, 4, 6. So if you take a moment to calculate, you will, okay, this is still not too hard, still have just 5 additions. Then but then as the cases go on and on, you will start to see that, oh, well, what the heck is the cases start to get like larger and larger, where your old method, or yeah, your old approach might not be very efficient. So in this case, we could really just throw you like a list of like it's the same problem, but now the case is getting very tricky or very large. No, it's like 100 numbers. So you definitely cannot just like do this with pen and paper. I mean, you can. In fact, okay, so the answer is just 5031 for reference. So you could still try to calculate manually with pen and paper. In fact, here I have the recording of like just me kind of just calculating this in the Windows 10 calculator. Then yeah, eventually you will get the answer of like 521. But then this one is like, obviously it takes a long time. It's very error prone. You have no idea how many times I recorded this already just to get it the correct one. So then yeah, and the time use is 2 minutes 30 seconds in the correct run. I'm not even counting the times that I fail. But yeah, so then you might want to like come up with so if like pen and paper no longer works as well, then you probably need something stronger, for example like with a simple programming like this, for example. So this is a demo of like how you could tackle this problem with Python. Yeah, so just copy paste, write some simple script. In fact, you can reduce this to one line, but okay, never mind. Yeah, so then obviously this is a lot more efficient. You just take like 40 seconds just to code. But yeah, so um s- okay, so I also mentioned before that programming is not mandatory. So so as a bonus, I included like some weird Excel trickery for you to work with. You can just copy paste, replace the comma with plus, and then change it so that it's a evaluation. But it's actually MCC is very free. Like it's very free. We don't necessarily like restrict you to only have one approach, but yeah, so the main challenge comes from trying to find a general or efficient method slash algorithm to solve the harder cases. So the smaller cases, sure, you can pen and paper, try to get a feel for the problem, etc. But then as the cases get larger, try to find a efficient method for it. Yeah, so then yeah, so this is sort of like the gist of like how what informatics Olympiad or competing Olympiad typically test for. So you have some solution. It might not work as well. It might work for some cases. Then as the cases get harder, then you might have to optimize it, etc. Yeah. So this is MCC, and the top scorer from NCC will sort of get will get invited, and they will have to undergo some more selection, MCO qualifying rounds to reach like the next main stage. It's probably MCO. We try to invite around 60-ish students for it. Yeah, so from here on out, it's a lot harder. You are required to actually implement the solution, a computer program in C++ or something. Yeah, so 4 to 5 hours, you solve 5 problems of similar nature to before, but but this time you have to actually implement the solution. You don't necessarily have access to the test cases, etc. Yeah, so after this, there's the APIO and also the APIO, which is like the sort of the Asia region informatics Olympiad. Then after all those, we just consolidate like the top 4, and we send those 4 to the IOI. I believe this is all.
Yeah,
Yep. Mm.
yeah. I see. So yeah, thanks for the introduction to like how the national selection test works for IOI. But I think there's a more important question here is that why is informatics relevant to Malaysian students? Like even if they aren't planning a tech career, yeah, we know like the uh, globalization era now is like all around technology, but still some may want to pursue a different career that is not quite related to informatics. So how does the importance of informatics relate to the students?
Right. So yeah. So why are informatics relevant, right? Like especially I guess for students that may not necessarily be interested in a tech career, and they might not want to become a software engineer, etc. But I believe that a lot of the skills that you learn from the solving informatics problem is sort of you can apply actually elsewhere. So first of all, at least in my opinion, the problem solving it definitely boosts your or trains your problem solving and critical thinking skill because because the problem the all these like informatics Olympiad tasks, right? It's not just like you know it's not like some straightforward stuff like I gave you as an example, but yeah, it's not like just some straightforward like calculate this sum or like calculate the multiplication, etc. You sort of have to find like, what's the optimal configuration, etc. So it gets harder and harder. So you you do have to well, comparing it to like I guess secondary school math, it's just like simple question and just one or two steps, then you're done already. Whereas here like, you really have to just like sit down, think of like, okay, what approach can I try, this approach, I can get this attribute, but it doesn't work so well, it doesn't run under the time complexity, etc. Yeah, so there's it just I suppose it trains you to be very to be perseverance. You get more and more patient with like a problem instead of like staring at the problem for like 1 minute you can't get it. I give up. Then just look at the answer. It trains your patience, and yeah, just then you will start to um so eventually you start to like look at the problem and you can start to consider like, I maybe I solved something like this before, but it's not quite the same. I can try like a lot of different approach, etc. Yeah, so okay, so other than that, like informatics is also like I would say it sort of unlocks the new way of thinking. So because you know it makes you very I would say detail oriented, because you have to when there's a bug in your code or something, you have to really trace step by step. Okay, so this variable is this value, uh, okay, this is expected, why is this variable this value, so you will have to be very like you will be very systematic and very step by step approach. Yeah, you'll be very detail oriented, I would say. And you'll start to be able to sort of like follow like, or at least follow along some long list of like instructions or like some long processes. Yeah, I would say that. Yeah, as I've mentioned before, it definitely trains your perseverance. You will start to be more patient, start to explore more path instead of like give up on the problem easily. And yeah, a lot of this stuff I mentioned is very applicable elsewhere. So it's not just you learn some XYZ algorithm and then you just apply to a software engineering job and use it. In fact, um, a lot of software engineering job or like computer science job, they don't actually require you to implement any of these algorithm whatsoever. But I would say you will still learn like some very valuable skills, like maybe good debugging skills, etc. Or even like just the normal stuff of like going through what's happening in the program. How do you trace through a process, like, or how do you break down a large problem? There's some bug, so maybe there's a bug in your code. Then maybe you want to try to like part of the isolate the code into like different parts and try to test out like, does this part have the problem? Does this part have the problem? And you realize that this actually is not just about programming. You can when you are dealing with like other processes as well, you can sort of apply this approach. Something went wrong. So how can we try to isolate the problem? Oh, okay. We can just, try to modularize or like divide it into sections and try to keep track of like, oh, so what's happening here? Is this correct, etc. Yeah, so I believe that a lot of the skills you pick up in informatics is actually very relevant elsewhere. And not to mention, if you learn some programming from this, it's very useful even in other jobs because there might be some tasks that's like very manual or like rather repetitive, sort these files, rename these files from small to large. Then if you are able to pick up like even the simple stuff like just write a simple Python script for this, then it will be very helpful lah. Yeah. So yeah, I think there's a lot of stuff you can pick up from informatics that doesn't necessarily just apply in the field of like computer science or even tech. You can sort of apply the skill elsewhere as well. Yeah.
Yeah, so I think it's like the soft skills that matter, and the whole how to solve a problem, how to debug, that matters
Right.
here
Yeah.
in
It's not
the
necessarily
progress.
like
Yeah.
the technical like algorithms that you will be using elsewhere, but sort of the way you think or approach a problem. You can definitely apply it elsewhere. Yeah.
Yeah, I see. So, Wei Xin, can you show us like one of your like favorite problems in MCC, MCO, or IOI? Like, how do you apply the soft skills that you learn like, to solve these kind of problems?
Right. I mean, so for me personally, I don't necessarily have like a favorite problem that I know keep close and dear to my heart all the time. People ask me favorite problem, I just give up. But yeah, but I like problems where I learn some like when I read through, okay, I couldn't get it. I read through a solution. So there's this new data structure that I can learn or like some. So I also like problems with like if it involves like some change in perspective or like some you tackle it from some other angles, then suddenly the whole problems becomes like a lot easier or more manageable. So maybe I can illustrate a problem. This is used in MCC 2017. It's not exactly a hard problem, but I think there's some nice property that we can sort of like keep track. We can see how like some change in process, changing the perspective a bit, you can suddenly the problem will suddenly become very easy. So like the problem could be like let's say you have n balls arranged in a row, so they are one straight line. So each ball is either moving left or right with the same speed. So the direction is different, but the speed is the same. And when two balls collide, they will they will move apart. So they will bounce and move apart with the same speed as before. So you have all this ball and they each one either left or right. They start moving. Each time they collide, they just move backwards. So now the question is just how many collisions will happen. So for example here, let's say the input is just n equals to 5. So there are 5 balls, and the ball's direction initially starts with like left, right, right, left, right. So then the answer is 2 because you can see here that here there will be a collision, become a left, right. Then here will be a collision, become a left, right. Then you will have left, left, right, right, right. So after all this, if you have the front part is all left, then the back part is all right, then they will never touch each other anymore, right? Then that's the end already. So in this whole process, there's just like 2 collision. Yeah, so you look at this, you try to like think your head of like, oh, uh, first of all, like at least for me, when I look at this problem, I would even think stuff like, how do we know the process even stopped to begin with? Like if I just look at the ball, later I go, I bounce something, I bounce back. Then later I bounce something again, I bounce back. Then how would I even know how many times I'll be bounced around, right? Like does it even stop or anything like that? So then if you play around, then you might try to like assign some sort of like attributes to it to sort of make it a bit more manageable. So to illustrate like the balls, right? So for example, this is just like 2 balls. They come together, they collide, and then they separate. So you might want to make it maybe a bit more visual, and let's say it's a bit magical, but sometimes when you look into it high enough, you can just sort of try to come up with this property. So maybe we can just say, oh, we just color a ball green if it is moving right, and red if it is moving left. Okay. So originally the left ball here is moving right? So this one will be color green, and this one is moving left, so it will be colored red. So yeah, as usual, they will just move and then collide. Then think of what happens when they collide. They will have to separate back, right? Then what happens to the color? The right ball will become moving right, correct? So what will its color be? Green, right? Then
Yeah, so they
similarly
will
the left
switch
one,
colors.
yeah. So they will just switch color, and then they will move back. That sort of you can think of it. You can just sort of like keep track of like the green color. The green color move. Then oh, it just continues and go on. So sort of like so it's sort of like the red and green, they will just cross over each other. You don't need to consider them like bouncing back. So this one it makes it a lot more clear now of like, oh, so I just need to know this green color, how many red color will it pass through. So now you already have the idea. Oh, it, I just need to know if let's say I have green, how many red balls do I have on the right side? So how many is coming towards me? Later I'll just pass through them lah. So each passing through is just one collision, right? Yeah, so you can so now it's a lot more clear. Oh, so the green must just like keep going right, the red will just keep going left, or eventually they will just all separate lah. And then I can even precisely tell of like, oh, when does a collision occur, etc. Yeah, so suddenly you switch like this perspective, like, oh, we color it red or green. Suddenly the problems becomes a lot more clear, or like a lot easier to think about. Yeah, so I quite like these problems where you see it from like another angle, then suddenly it becomes a lot more manageable. Yeah, so something along these lines. Yep.
Yeah, so it's like a different change in perspective that makes these kind of questions like very like palpable, I guess. Like, because when I heard the problem that you just described, I was thinking like, oh, so eventually it will become something like a sorting problem. So for people who like know computer language, they will think of this as a sorting problem, like zeros and
Yes.
ones. Yeah,
Um.
so
mm,
yeah, I think it's quite interesting.
mm.
Yeah. So as your like participation, like you participated in IOI before, and now you are the team leader. Like I'm sure you have a lot of photos for the participation in IOI. Can you show us some of the photos, like how the competition actually looks like? So like students can actually get engaged. Oh, so this is how the competition looks like
Can
when we
can
are
can. Yeah.
doing
So
this.
so this is where the advertisement come in, or like
Yes,
you
yes.
see like all these places we go to, come, you can join us. Yeah, so okay, I didn't really prepare much like excursion photos, so but I guess I'll just start off with like team photos. So actually the Malaysia IOI scene is actually very young. We only started in like 2012. So I'm sure here some faces that you recognize, Mr. Su Haimi, Dr. On Jin, which is the founder of MIPS actually. So yeah, the Junyuan, the others I don't really recognize. So these are previous me. So this was 2012 in Italy, and 2013 in Australia, 2014 in Taiwan, 2015 in Kazakhstan, 2016 in Russia, 17 in Iran, 18 in Japan. Yeah, so I was there. That was the first time joining and last time. Then after that, going as the deputy leader in 2019 Azerbaijan. And 2020 and 2021 in Singapore, but because of the whole pandemic thing is held online, so unfortunately there's no photos. But yeah, so if you get to if you compete, fight it out, and you get to join the team, you get to visit like a lot of interesting places, because you don't just go there to compete. Actually the whole IOI is like it's either 1 week or 10-day program where there's an opening, etc. You don't just like go there, compete, or get a medal if you can, and go back. So you actually get to like explore around the host country, try to try to experience their hospitality, etc. Um, in fact, we try to make an effort of like for each IOI have the team members try to report like what they saw, what was the trip like, etc. Yeah, so a lot of this you can find it on our website like roi-malaysia.org/news. Some so these two are like from the Azerbaijan. Then this is like is in Azerbaijan there was like a hill that was always on fire or something. Then this was from Japan. Yeah, so you get to so going to I is not just just competing and try to get a medal. You get to see around, see what their culture is like, and of course you get to like meet a lot of friends as well. um you're competing with like some of the other countries that are top four as well. So you get to know them. You will see like it's a very interesting experience. It's very eye-opening, I would say. So so it's I hope I try to make it sound attractive, but it's very eye-opening, and you should try to get it if you can.
Yeah, so it's a good opportunity for the students to actually to look to go to travel somewhere around the world and just like meet people,
Hmm.
see all the attractions, etc.
You get to go travel. You get to see attractions, eat good food, solve interesting problems. I'd say it's quite a treat. yeah
Just having a good timeline in
yeah
general.
yeah yeah. Mm.
Okay, yeah. So maybe people are wondering like how are Malaysians like performing in IOI? Are we doing good? Like
Mm.
since we are a new team, right? We started in 2012, as you just said. Are we doing well?
Yeah. So here I already have like the previous years like results starting from 2012. So okay, so we don't necessarily okay. I think starting from like 2014 or 13 actually we start to have okay. So actually from this I want to highlight that so it's really not just being good in programming alone is really not enough. It's not like C++ and all its syntax and I can use this hash table, etc. Having that alone is not enough. You actually need good problem solving skill and vice versa as well. Just because you have good problem solving skill alone, it's not enough. If you can't code it out, then it's useless. So in fact, you can see that here. If you recognize this medalist name like Hao Siyu, uh, Yun Kai, Justin, Zisong, you might recognize them from IMO as well. So it really goes to show that you really need to be a good problem solver to stand a decent chance against others as well. Yeah. So this was 2013. I will probably just highlight 2018, the year I went. So this is the first time that Malaysia got their first gold medal in IOI by Zisong. Then after that, I would say the next biggest year is actually just last year. Malaysia managed to score 3 bronze. So it's almost the whole team got bronze as well. Even um the participant that didn't manage to get it, he was actually relatively close to getting a bronze as well. As you can see, the relative ranking is 47%. So he just needed a bit more. It would be a full bronze already. But I would still say that this is a very good year as well. It shows that it sort of shows that at least like the floor of like the participants is slowly pushing up. So instead of like having one very high ceiling, then instead there's sort of the base performance is sort of getting there. The participants obviously work very hard for it. So we had last year was the good year. Yeah. So
Yeah, so I think that's quite good. It's like it may be our nation, we people, Malaysians as a nation, is actually performing better, and the more people are interested in problem solving, interested in programming, etc.
mm,
And I'm sure like we also all hope that the performance will get better and better. So like, why should the students join MCC, MCO, IOI? Like, or what traits do you look in potential students that these guys may have fun in participating in the Informatics Olympiad?
right. Okay. So I would primarily you should still join to because you like problem solving or like just solving puzzles, etc. But maybe you're more interested in like maybe the practical side of things, or I'll probably still a pitch from I forgot which one is this, but yeah, if you get good results in these competitions, IOI, if you bag a medal, a lot of university okay, you will, of course you will have to check with the universities, but a lot of the top universities, they will actually look for your participation, or rather if you or your result in these competitions actually. So if we take NUS for example, if you manage to get a medal at all in IOI, it is a auto admit already. So you can just say, hey, I got a medal, then they'll just take you in, and of course you have a higher chance of getting the scholarships, etc. as well. So good career prospects. So I would say, so I think it's not really a big secret anymore that CS jobs are well paying. Let's say well paying, and yeah, and obviously if you do IOI, you're probably interested in computer science, and probably will take up some CS job. Yeah, it's a good career prospect, and I would say this is one of the good thing that Informatics Olympiad has over other Olympiads is that you don't have to worry too much about interviews anymore, because okay, so if you apply for like let's say a software engineering job, typically they will actually give you like a coding test, and then as a selection, then of course there are some other interviews part. So for maybe for others that didn't compete in this sort of thing, they will have to prepare for the coding interview. In fact, there's like, there are like a few books or even like a few courses on like how to do like the coding test or like coding interview, the DSA. But for us, it's just another problem, and typically the one tested is actually very simple. So yeah, so you get the benefit of like just being good at coding interview, and you don't really have to prepare for it anymore. You can just focus on like other stuff, maybe like some more relevant stuff like design decisions, etc. Yeah, so I would say that this at least um is directly almost applicable to like landing a job. Whereas if you okay, I don't think I'll say it. But yeah, so yeah, then I guess but like, I would say like the main point is just that it's still fun. It can seriously get addicting if you have the time and you invest in it, or you start to go down the rabbit hole and see like, oh wow, I can actually find the minimum spending tree using this and this, or I can sort it using this, or if I have this property. So you start to there's a lot of stuff that you can suddenly do. And yeah, even if you learn like the most basic stuff, I would say it's very beneficial already. In fact, like you don't even need to like, even if you just pick up like very basic programming, right? Like you can already apply it elsewhere. It's not necessarily just it's not just a tech jobs that need programming. If you know it elsewhere, the batch scripts or anything like that, it's immensely helpful lah. Like you get to focus on like the more important part instead of like sort of some part that can be automated. Yeah, so yeah, I hope I made it sound fun.
Yeah, hopefully like people who are interested can see hey, the benefits they can reap from participating or just trying in the informatics Olympiad. So here's a problem here's a question that I think most of the audience may be interested in. So like, since programming is not really included in the Malaysian education syllabus, like, if the students are interested in participating in the informatics Olympiad, they may want to have some resources they can refer to, or like, hey, are there any like tricks or tips like they can know before they jump into this very deep rabbit hole?
Right.
So yeah,
So
any resources for the students?
yeah, so this is like one of the funny thing of like the about IOI, right? It's sort of everyone is starting from scratch. Whereas for IMO, physics, chemistry, biology, some part of it is already taught in school. So there might be some like different starting point. But for IOI, well, the closest you have in school is IT, as far as I know, which doesn't touch almost I would say didn't touch anything about this at all. So everyone is sort of start at the equal ground. So if you just work for it, you can actually, you will probably have a higher chance to win against others. Yeah. So okay. So yeah. So how do I, how do you get in? How does someone that's interested, how can they get involved in this, etc. So first of all, obviously try to keep out for the next selection process. The current selection process for the team this year in 2022 is already underway. But if you're inspired and want to try out for IOI 2023, then you start by looking out for MCC 2022. You can keep an eye out on our website for when we announce it. So there's a lot of resource online. Okay, so yeah, so this is also one of the good thing for IOI as well. Because I believe at least for the other Olympiads, IMO, IBO, you sort of have to rely on past questions, right? There's not like actively new set every day for you to do. Whereas like programming competition is actually very common now. It's very popular. So you can there's a lot of site with like active community actually actively contributing new problems for you to solve. Like let's say so USACO.org is a USA Computing Olympiad. So yeah, you can train there. They actually have a guide of like there's a USACO guide on you can study. So how they work is they are split into different divisions based on your level. So you start out like bronze division, go up to if you do well enough, go silver, go platinum. So they have a guide for each division for you to study like, oh, what are the some of the fundamentals that you should know, or what's binary search, what's a fan victory, etc. As you go up. So it will teach you some of the basic stuff that you need to know to perform well at a high level. Then there are also sites like Code Forces and Coder. So these are where like I think if you go almost like every week, there's a new contest there for you to do. So it's not like the math competition. You have to maybe wait for like some organization like some SMO or something like that, and only you get to experience new problems, or you have to really dig into like the archive of like all the past like math problem. Whereas here, there's really like new problem for you to solve, like and sort of yeah, if you yeah, so there's a what I'm trying to get is that there's a very active community, and there's like fresh resource for you to consume as well from these code forces and coder. They actively host competitions for you to learn from lah, do and learn from. Or you can even consult our own website or Malaysia. We currently also have the effort of like try to archive our past contests problems and solutions as well. So you can actually try to learn from it as well. Obviously, there are also some I didn't put it here, but there's also a lot of reading that you can do. So for example, there's the what's that called? The Competitive Programmer's Handbook. You can just Google it and you will get the PDF for it. Yeah, so that's one. In fact, when I started out, I also quite often use it as a reference. When I forgot something, I just did a quick revision. Or there's also the Stephen Halim's currently he published recently he published CP4, the low bound of competitive programming. So it will also teach you like the basics that you need to know, yeah, to get you started on somewhere lah. Yeah, so it's definitely yeah, if you go look for it, there are definitely resources there for you to get started, and to continue train even for at all levels, I would say. Yeah, so
Yeah, that sounds good. At least there's an like engaging community for the students to actually get involved into. I think that's quite important. Like, yeah, I think that's a very nice perk that the Informatics Olympiad has. So maybe like a few more things that like for someone who like doesn't know programming and he wants to start. like is there any like recommended like language like for the IOI? Like is C better? So someone learn Python. Is the syntax necessarily to learn, because we know that programming syntax is like quite elaborate and
Okay,
messy at
okay.
times. Yeah, is
Yeah,
there
yeah.
any advice for the students?
Right. So, hmm. Okay, this might be a bit controversial. So typically, we try to recommend new students to just pick up Python as a beginner language. So because it's not as strict syntactically. No, a lot of stuff is just yeah. So Python is not very strict on syntax. So the students don't really have to worry about like the sort of some of the more declarative stuff like semicolons, etc. You can just go. Uh, but the yeah, so typically we would recommend that as like a starting point for a student. Just learn some of like the very basics like structure of a program, like what's a function, what's a while loop, what's a if, what's a array, etc. Because a lot of these they actually translate quite well to other programming language. So there's actually so actually if you know a programming language already, it's actually not too hard to transfer what you know to another language. You just need to know like, okay, sure, so let's say you're quite familiar with Python already, you know the conditionals, the loops, etc. If you try to transfer to C++, yeah, it's not too hard. Sure, at the start you might get tripped up by like the syntax error, etc. You're missing semicolons because you didn't learn that in Python, etc. But all the basic building blocks or like the structure is all there. You just need to translate it properly, and yeah. So I guess it depends on the. Okay, so because I should mention that I suppose at high levels, not necessarily high levels. Okay, let's just say take IOI for example. So IOI they actually don't allow any other languages other than C++. So for us MCC we don't care like you don't use a programming language at all, it's fine. We just let you do pen and paper. But yeah, so from there on like even after right after MCC actually all the qualifying tests you do onwards, that's MCO qualifying rounds typically held on USACO. They allow Python, etc. But after that will be more strict. Like from MCO onwards, it's all just like it's just C++. Yeah, so it depends on like if the participants really want to start with C++ straight ahead, I won't not recommend. So I would say if you want can just go ahead. You can look up like some C++ guide, and in some sense C++ is also a bit more rigorous. It's more detailed. So you actually know what's going on, or like you know that oh this variable is a integer type, or this variable is a string type. So whereas in Python there's no type to begin with. So 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 yeah, uh yeah, I mean I suppose it depends on the student. If you really just want to get started somewhere, you want to pick up Python straight, yeah, go ahead. In fact, Python is also useful for stuff like you want to write simple scripts maybe for your schoolwork or your work, you want to rename some stuff. Python is something that's not very time sensitive or needs to be very fast. Sure, just Python a few lines, just go ahead. Then to get you started. But yeah, but as you progress upwards, then you should start to learn C++ already. Or if you want to start jump in C++ straight away, that's also fine because it also it forces you to think more rigorously. What what sort of what libraries am I working with? What data structures are there? You will be more clear in your mind in some sense. So there's no like a definitive starting point, I would say. But I guess the most popular one would be Python. But if you want to start with C++, go ahead. It's the world is your oyster.
Yeah. Okay, I think that's quite informative, and I think like our audience can learn a lot from this interview. Like, does Wei Xin has anything left to add to our audience? Like any words? Like,
Right. Uh, so I would say, yeah, don't be too stressed about like, oh, how do I get started? What's the optimal learning route, etc. A lot of this is pointed to just do. Just pick up some guide and just go already. You don't need to know like a lot to begin with. It's okay to start out like, oh, there's some stuff that you're still not clear about. It's okay. Just go. In fact, that's probably like the fastest way you can learn by or improve in competition. Okay, so maybe I'll just give like one tip of like getting good at informatics is really just go ahead and do problems. You don't care. Okay, so code forces there's a rating system. Depending on your performance, then they will assign you a rating, or you're cyan, you're blue, you're orange, etc. Don't care about those. Those are sort of just superficial, big quotation mark, but you know try not to take those too seriously. Focus more on like the actual problem solving part. What can you extract, or you didn't get this problem, it's fine. Or so look through the editorial, see what techniques they use. Wait, this is a nice trick, I can apply this next time. I try to go through and figure out what's the rationale behind the solution, to internalize it, so that next time you see some problems that are similar, you see, okay, I can modify it this way, so that it translates directly back to the previous problem that I solved, or something like that. So I would say one of the key to getting good in this is really just do as much problem as possible. Try to actively join these code forces at Encoder contest. Look at the solutions. I mean, if you just join and then you don't try to upsolve the things that you miss, then you probably won't improve as much. So it's really important that you try to be actively participate. If you didn't get the problem, it's fine. Just upsolve it. Learn what's the rationale behind their solution, etc. Then yeah, you try to have fun. This is not it. Uh, yeah, don't stress yourself out too much. Oh no, I couldn't get this. Blah blah blah. Try just take it normally. This is just like learning a new skill. Just try to have fun doing it, and you'll get good at it naturally.
So basically, practice makes perfect and enjoy the process.
Yeah,
Yeah,
yeah, I couldn't put it better myself. Yeah, try
yeah,
to
okay.
enjoy the process. Correct.
Yeah, okay. Thanks, Wei Xin, a lot for like today's very informative session. I think everyone learned something new. So this is the end for our session today, and thanks for joining us.
All right, thank you so much. Bye.